This time, let's try to operate vectors. Now here, we have a combination of vector addition and scalar multiplication. And there are some also important concepts that needs to be remembered, especially when operating them, because later on, as we move further on some topics here in analytical approaches to modern geometry, we are going to really use them. So we have here our x, y, and z vectors in R2, and we have here these components. So we are first tasked to solve the sum of x and y vectors. So x plus y is simply adding the two vectors, right? So the components for x is 2 and 3, plus for your y is 3 and negative 4. Vector addition allows us to operate or add, like in addition, component-wise. So this means you have 2 plus 3 and 3 plus negative 4. If you can answer it immediately, then why not? I'm just trying to show here the step-by-step process for more comprehensive discussion. And hence we have here 5 and negative 1. This is x plus y. And take note, as mentioned in the first video in this playlist, this is still closed. An element of R2 because vector addition is closed, right? Or there is a closure property. Okay, we may not include this because it's already clear. For our second item, you have here twice vector z, and take note, this is scalar multiplication, and still scalar multiplication under vector space, or in this process of R2 is closed as well. So this is just simply equal to twice. Let me rewrite here. Twice z means twice times the component of z, 5 and 1. So simply distribute the scalar. We have here, again, I'm doing this step by step, 2 times 5, 2 times 1, which gives us 10 and 2. So this is the result, or for twice z. By the way, if we are going to look into twice z, that means we are extending z. Okay, we are actually extending that. We'll have more illustrations for that later on. Now, let's proceed to y minus z here. Now, for y minus z, this may not be addition, but of course, you can always rewrite that. Okay? You can actually write that as y plus negative z. Okay? That's actually one of the things that we can apply here, so that we can really work on the addition itself, because there's no vector subtraction. But nevertheless, subtraction is the reverse operation of addition. And at the same time, if you will stick with this, it's still okay. I'm going to show you the other process later. That's still probably acceptable. So for y, you will have here 3 and negative 4. You have here plus, and then the negative of your vector z, which is 5 and 1. And 1. Okay, take note, you have here negative 1. We know that already as one of the properties, scalar multiple, right, in a vector space. So it also has 1. So you have here 3 minus 4 plus, you will have here negative 5 and negative 1. And then you can simply add them. You have 3 plus negative 5, negative 4 plus negative 1, which gives us negative 2 and negative 5. This is y minus z. By the way, I'm showing you this method or this step because this is actually more appropriate, but some strategies will actually look like this. Simply 3, negative 4, and then you have minus here 5 and 1. Okay, this is also other method, but this is actually the longer method, which allows us to appreciate this shorter method here. That's actually 3 minus 5, and you have your negative 4 minus 1, which still gives us negative 2, negative 5, the same as that. If you're doing this, other professors will accept that, it's okay, but it is actually more appropriate as we're looking for addition and scalar multiplication here as part of a discussion. Longer, but more comprehensive because we are trying to review vector addition and scalar multiplication. Nevertheless, again, some professors will accept this. Now, let's move to the last one, and hopefully, my spaces here are enough. Okay, it's not enough, so let me start here. You have x plus z minus 3y. Of course, you can write this as x plus z, as mentioned, plus negative 3y. I'm just going to do it like this, even if, again, this is acceptable for some. I'm just going to do it like here. So let me do it like this. X is 2 and 3. So you have 2, 3, plus your z, which is 5 and 1. Right? Plus, again, I'm using plus, negative 3 times your y, which is 3 and negative 4. Okay. Now, step by step, adding these two, as mentioned, step by step, let me do it like this. 2 plus 5, pardon if this seems very long, but I would like to do this. Okay? So I can actually remove this one open parenthesis here, and that's okay. And then you have your plus, so you'll have here negative 3 times 3, and then negative 3, that's 3, sorry, times negative 4. That's actually, what is this? 7 and 4, plus negative 9 and positive 12. And after this, simply add 7. Again, I'm doing it like this. Pardon for that. And then 4. If you can do it automatically, why not? Which gives us negative 2 and 16. This is the result for it's okay. X plus y minus 3. Sorry, x plus z, my bad. X plus z minus 3y. How about trying not making this addition and automatically just like this one here, proceed to the subtraction? Do we get the same result? I would like you to do that on your own. Try to verify if you will have minus 3y immediately. So you have minus 3 times 5 is minus 15. So y is 3, right? So negative 3 minus 3 is negative minus 9. So still 7 minus 9, that's correct. And then you will have here negative 3 times the second component is negative 4, that's positive 12. So whatever the result here, 4 plus 12, it's still 16. I believe it's still okay, but you could try that on your own and we will still get the same answer. This is how we operate vectors. So simply try to look into the correct processes of adding vectors and multiplying a vector with a scalar. Thank you very much for watching.